Okay, today we're going to learn about ratios, proportions, and geometric mean. This first video is only on ratios. Ratios should be a review for you. We've been doing ratios probably for many years, but let's take a look at what geometry has to offer with ratios. I always say ratios are really easy in geometry, and you'll see why in a minute. So, as you know, a ratio should be written in one of three different ways. They're all pronounced the same way though. So this is a ratio of A to B, this is a ratio of A to B, and this is a ratio of A to B. For example, if they wanted you to write a ratio of the width to the height or the height to the width, since we have 5 inches and 10 inches, since the units are the same, we can just write the ratio 5 to 10. Of course, we always want to put our ratios in simplest form. So 5 to 10 is equal to 1 to 2, just like the fractions are equal. Those are called equivalent ratios, just as they would be called equivalent fractions. It is really important to remember that ratios should always be in simplest form. That's really important. So you always want to reduce. I think I said that the ratio of the height to the width or the width to the height. You really have to be specific. In this case, this is the ratio of the height to the width. If they wanted the ratio of the width to the height, then it would be 10 to 5 or 2 to 1. So it is really important to be specific on that. I want to do an example with you. What if the units are not the same? For example, 5 feet to 20 inches. Well, since I know that there are 12 inches in a foot, I either need to make both of these feet or both of these inches. And so I'm just going to rewrite this to begin. And if I want inches to cancel, I'm going to put inches on the top. We're going to multiply by a fraction that is equal to 1. And so I know that there are 12 inches in a foot. And as long as I multiply this, by a form of 1, we're going to be okay. So we're going to do 12 inches to 1 foot, and that is equal to 1. And so then we're going to cancel. So inches cancel and feet cancel, which normally we don't want all of our units to cancel, but for a ratio we do. We want all the units to cancel. So that's going to be 60 to 20, which of course is 6 over 2 or 3 over 1. And so that is a ratio of 3 to 1. And you can write it this way, or you can write it this way, or you can write it this way. But that's a ratio of 3 to 1. The last example I wanted to do, and this is more often what you'll see in our geometry class. A lot of times they'll say, I have a triangle and the angles are in a ratio of 1 to 2 to 3. And oftentimes they won't give you a diagram. They'll just say, find the measure of each angle if the angles are in a ratio of 1 to 2 to 3. And so what you want to do is, I usually just sketch a triangle. Clearly it's not isosceles or equilateral or equiangular, so I drew a scalene acute triangle. And so the largest angle, look, appears to be here. So I'm going to call that 3x, and this appears to be the smallest angle. I'm going to call that 1x. And I'm going to call that 2x. And so it's just that easy. If they say the ratio is 1 to 2 to 3, 1x, 2x, and 3x. Of course, we know that the interior angles of a triangle add up to 80 degrees. So we're going to go ahead and make an equation, because we took an algebra class and we know how to do that. So that's going to be 6x equals 180. X equals 30. Now, depending on what they asked you for, in my case, what I said was I want the measure of each angle. And so we're going to plug back in to these. So one angle is going to be 30 degrees. Another angle is going to be 60 degrees. And the last angle is going to be 90 degrees. Of course, I didn't know that when I drew my diagram. So if your biggest angle doesn't appear to be a 90-degree angle, that's okay. But we now know, based on this information, that it is a right angle.